All right, with great expectations, great disappointments. I really thought this will work, and it appears that this driver is a bust. Is not working at all. It's giving me all sorts of error. If I'm touching my table here, it's behaving in one way. If I'm lifting my hand, it's behaving in another way. It's very random. See, very random, very random. Uh, Usually this behavior is when the inputs of some logic gates are not grounded or put to positive or whatever, positive or negative. Uh, this is a sign of a floating gate when you see behavior, erratic and random behavior like that. And I did put these lines here, and as you can see, if I'm clocking, so you see, if I'm lifting my hand, everything is disappearing there on the first digit. But in the moment I'm touching my hand to the table, the others are showing, and also probably that one as well, yeah, a little bit. And if I'm clocking from here manually, it's not. It should have incremented. It should have displayed 1, 2, 3, 4, 5, but it's not. One thing is that, well, I'm powering with 5 volts there, but I'm dragging the power. You see this little wire here that is going to the rail? It's actually from the 3 volts there. It says there, this is 3 volts. And all these chips are powered with 3 volts. Theoretically, it should work if I read. It's not even 3 volts, it's 2.8. And I blame a little bit the power. Now when I'm at this stage of testing, I linked this pad with this pad 40 with 1 because the LCD is having the same the same pads, 2 pads, for convenience probably. But I linked them together just to be sure it's not from the other pad that was left in air, and it didn't solve anything. It wasn't that problem. And then I tried to do this. I don't know. I really don't know how to solve this problem. I really don't know. It's very bad what I'm having here. Very bad. Shit. And I remember on the tests that I did on the breadboard, everything worked super. And here, bam. I was so sure it will work. And it's giving me this kind of shit. Well, not every battle can be won. You lose some battles. And I spent a ton of time building this driver. Holy shit. Yeah, well. Alright, thank you very much. I hope you are disappointed as me on this thing not working in reality. I'm also blaming the cardboard a little bit, maybe because I'm making everything on cardboard, but it proved in time that is not an issue. It proved me many times. It's fine. But who knows, with these LCDs and these gates, everything is new. That's what I'm doing. I'm experimenting. And I did very sensitive stuff with cardboard, and it worked quite well. Even a frequency thing that was very sensitive to frequency. And it worked that as well. Well, shit fuck. This, I believe you can see the flickering, and the flickering is because of that capacitor there. A little bit when it's displaying, but it's quite okay. It's quite okay. I believe if I'm increasing that capacitor value, it will flicker a little bit faster, and actually decreasing the capacitor. So making a smaller capacitance there, it will increase the frequency here, and yeah, shit. So after the erroneous behavior of the LCD driver, I decided to take it out. It passed like 2 days actually until I decided to take it out. I tried everything. I really tried everything. I even built another board here. Let me power it up. And I look back on my previous videos. I made a video with this prototype that I built here, and I literally copied it and I rebuilt it here, and it's working fine. I have a single problem here with this motherfucker voltage regulator that is not actually giving me the voltage that I want for some reason. Probably this guy is busted or something. I have no idea. Or it's interfering with all this logic somehow, but it's not giving me the 3 volts that I want at the end. So I have to actually put another resistor here on the output. You see, between the output and adjust voltage is 1 kilo as it should be, but then I added another 1.2 kilo here. So 1 kilo there and 1 kilo there should have been giving me 2.5 volts from 5 volts, a half of the value, right? But it's giving me 3.8, almost 4 volts all the time. Probably this guy is busted. I have no idea. And then I put another 1.2 kilo here, and it's kind of divided the voltage a little bit, and is lowering the voltage. But other than that little shitty problem, everything else is working and is looking fine, absolutely fine. Let me film it like that. You see, last time when I built it, I didn't film the circuit too well, and I had to really get back and forth on it. When I had to rebuild it this one. So I rebuilt it here. It's working fine. It's numbering there. That's what it's supposed to do. That is what is supposed to do my driver here. And it didn't. It only gave me all sorts of errors and no kind of numbers whatsoever. What I did before I disassembled it, like you are seeing right now, when it was already assembled, I took the inputs here, some of them, well, all these inputs actually, and then some of them on other tests. But on some tests, I put all of them, and I linked them to this 4033 here, also to the 4110. I plug it plug it in here, and I drag the wire to it and made the necessary connections for it to the necessary settings for that specific chip. And it still gave me the same errors. If I paid attention, it was bleeping all those errors that was showing. They were pulsing in the same rhythm as my pulse, but they didn't show this. Didn't show me the correct numbers or digits or the correct sequence of segments. Pretty much, this is the correct sequence of segments that what you are seeing here. But here, with this driver, it was busted. It was busted. Remember when I said it will be a miracle if this will work, because I put some wires was touching near each other, and my best guess, something got shorted after all. So this might happen uh, most certainly this might have been happen. I have two wires, or at least one wire that is shortening, at least one. My best guess, I have multiple wires, not only one, I have multiple. Because I did feel when I was making the hole, when I was poking through the cardboard and I was making holes, I was feeling I am touching those wires, and something is touching there, and that's why I got all that erroneous behavior. Like I said, I tried multiple ways of linking and trying to make a digit here on the display while everything was completed, and all the ways that I tried failed. I tried like 10 or 15 ways of trying to make to see a digit here, and nothing, absolutely nothing. If I disconnected this pulsing this guy, if I disconnected it from here, if I disconnected this guy here from there, everything didn't show anything. It was blank, no errors, but also no digits. So I changed that capacitor to a faster one. I changed the output directly from the pin, as you can see now. It actually have to be from this side after the 10 kilo resistor that you can see, that small one there. I changed that resistor there. Actually, on this voltage regulator, I do get 3 volts, no problem. Probably that is certainly busted. This voltage regulator. I did test him quite a lot, and it probably give up. No, I don't have that many of them. Yeah, what else? Yeah, and last night like I said, I'm working with brakes. In one of the brakes, I was extremely disappointed of the final result. I was expecting to work, and it didn't work. With high expectations, also high disappointments in the end. But then the cool thinking prevailed, and the logic thinking prevailed. And I remember this morning, actually, before I wake up, I remember that I had those small contacts. Probably. I'm not sure. I tested. I checked everything that I linked there, and nothing seemed to short. But who the fuck knows? Who the fuck knows? So what I did, I took out. Probably it's as being as close as I put them without actually shortening. Like 2 wires being just close with isolation, with everything between them, but being too close, maybe they are interfering between them. I'm getting to those type of conclusions. Observing the behavior and the error that I had, and I am terribly susceptible right now, extremely susceptible. So my next step was to take it out, okay, because this is busted. 100% is busted. It's not good, not bueno. It's damaged completely. It's a fail. And then I took out this chip. Taking out this chip from here was harder than I imagined. Was a little bit more harder. Why? Because of this. I took everything out with this very long needle that you're seeing here. Everything. This long strips and this chip as well. Because I was inserting it and bending forcefully the wire until it snapped, while I was using my soldering iron, of course, while I was hitting that specific element. And when it snapped from there, but I had to do it multiple times, not one time and that's it, it snapped. Nah. I had to do it multiple times. Here are the connections, and there. And also here, because of this very small, you see this small and fragile wires here, this was a bit more complicated and a bit more challenging to take them out, this very small one. These bigger ones were a bit hard to bend because they are bigger, but in the end they give up. These were very easy to take out because they were on the surface here. I could see exactly what I'm doing, but they're underneath, not really. So that's why it was a bit too hard. So my next step, that's why I took out this chip. I took it out and I planned to make one single digit exactly as you are seeing here, to replicate this circuit that you are seeing here on a single board. So I'll make one single board, one single driver for one single character. This I should have made it like this from the very beginning, but I got hero. I got like a hero, and I said, ta-da-ta-da, I will make it and it will work, motherfucker, and it didn't. Great disappointment. Great disappointment. But I'm getting back to to the horses, and I will make it work. First of all, I'm not promising anything that I will make it work. Probably there is some sort of interference between, it might be this possibility, some sort of interference between the LCD and the cardboards and the wires. It's like a very bad combination. It might be. I'm always thinking these cardboards are not really perfect for doing electronics. I'm always having in my head this option, But as dark as it sounds, I built a ton of circuits on cardboard, so I'm not starting. I already know that cardboard is efficient as any other material that I'm using, and it it is good enough. It is good enough to build, especially prototypes, chip kits. So I don't really believe that the cardboard is the problem. The combination between all of this is the real problem. I strongly believe it was a short somewhere, and I couldn't detect it. Or even, like I said, even two wires too close together, and they interfere each other. They influence each other pretty much, and that's why I got all those errors. Most probably, it must be it. Another idea was that the combination between these chips 4030, you see 4030 chips, and this 7486, very small one, this combination between the gates, maybe this maybe created the actual error. It's like an incompatibility between the gates themselves. Who the fuck knows? But I was thinking on possibilities why the error happened. So this is all that it crossed my mind. These are all the versions, all the possibilities that crossed my mind, and I'm trying to tell them here in the video, all of them. I'm trying to tell them as much as I can. I did have way more ideas than all I'm presenting here, but I'm presenting the bigger, more important possibilities of why it didn't work. So this is it. This is it for now. So this is my plan to rebuild one single digit on a single cardboard, on a single cardboard with all the correct outputs, exactly like you are seeing here, but with much more care for wiring this time. I will think very hard how I will rewire everything beneath, in the idea that should not interfere one wire with another, to be very well lay out the wiring. So yeah, it's a lesson. It's a lesson in wire layering and wire construction, pretty much wire design. When you design something, the track design and wire design. This is a big lesson for me. This fail, and I should have made the wire design in 3ds Max from the very beginning, all of them. But I got lazy and I said I got Hero, and I said I will make it as I go, and I only made only the output wiring, and that's it, if I remember right. Yeah, only the output wiring and the power wiring, but not the other input. This input wiring, I didn't made it in 3ds Max, and another wiring. No, that's it. And also this 100 hertz frequency, common frequency, that one I made it as well. So 3 layers of wiring I did made, but I didn't made this secondary output from each gate wiring, because this was too much here. But I should have made at least for one and see how the layers were. I didn't check actually in 3ds Max. I didn't look between the layers. I didn't made it on layers. This is a lesson to actually make it in the future on layers and look between them and look how everything is moving and showing, and to leave more spaces, way more spaces. I do like the spaces that I'm having here. It's very well designed, like it is right now. That's why I was very disappointed, because I really like the design, how I lay it out here. The components, perfect. I didn't want it better than this. It's just perfect as it is. The distances, I could work on them, absolutely no complaint. But the only complaint was the wiring and how to get through each layer of and not touching them, trying not to touch them. But evidently I did touch something there. By the way, I'm not stupid. I did check everything that I made with my multimeter here, and nothing is shorting. Absolutely fine, everything. But somehow it is a strange error there. I cannot explain how. So that's it. I will remake this module, one single module, and we'll see after that. I will replicate actually what I'm having there. I will replicate it on a single board, and that's it. Hopefully I will find the actual problem. See you next time when I will find it. That's it for this part. I forgot to mention that if this one single chip test that I'm reproducing there, this single chip test will actually give me the digit, and everything will be fine, even with these different gates models that I'm having there, then it will tell me that definitely the wiring is messed up on this board, and that's the main cause. Right now I'm only suspecting it is. It might be something else, but if it will work seamlessly like it was working there, like it is working here on this breadboard, then it will tell me yes, it is the wiring. So the next stage, after I will make one single digit here, I will take out all the layers, everything. I will take it out, everything, back to the beginning here, and I will rewire everything back again and rewire it a bit more smartly, hopefully, than I rewire it right now. That's the idea. I hope. I don't know what to hope at this point. I really don't know what to hope at this point. We will see. But that's the idea. Right. I made another board with the display, and there is the driver here. And I discovered something when I first built it. It doesn't have any errors. When I'm putting my hand on the table, Pro is getting some errors. But if I'm lifting my hand from the table, it's fine. Probably my 50 hertz from my hand is getting somewhere there. I discovered something very, very interesting. When I first built it on this cardboard, it didn't work at all. I connected all the same wires that you are seeing here were connected in the same arrangement and the same setup as you are seeing here, and it didn't work. Zero. But if I was moving the entire LCD, sometimes I got 1 or 2 segments running randomly, and then I figured it out that it was playing in this original socket. The pins of this LCD display are very thin, and they are not actually making that of a good contact inside the socket. So what I did, I took out my can, my cylinder of connectors. I have them. I have these for a very long time, and I had I had them as very long like this guy here, but I cut them to fit here in this. And I knew I was making a big mistake, but I did it anyway. For a very long time, I have it from when I was an adolescent. This box, round box, with connectors like this. I gathered them, and yeah. So this is how it's looking. One of them. Uh, I hope you can see. You see, it is having like a spring contact there, and in between these two contacts, that very thin leg of the LCD is squished pretty much. Is fitting extremely well. Is pressed, while in this type of connectors, it was running loosely. It was moving like that. It was very loosely. This might have been the cause of all the problem that I had. It might have been. Like I said, it didn't work at all when I first plugged it, and with some very random segment running when I was putting my hands on it and moving it around, But now I am extremely sure it is making a very, very good contact. And what I said before, that I made a very big mistake by cutting them, and I knew it back then when I did it, but I did it anyway. So I also left this long, one or two, not that many, and I was very lucky to find such long strip bar for both sides. So these are my last ones, this long, and I will have to make a better design next time when I will use these small ones for the next LCD probably. But so far so good. I mean, this was a very possible cause. That's for the driver not work. So my plan is to put back that chip and to try it again, to take it from here, move it here, and try another experiment with these connectors that I'm having there. Very, very strange. Very strange. All right. Okay, I immediately I changed these ports, so I have the new ports that are making a very, very good connection right now, extremely good connection. There is no doubt there. And I mounted everything back as it was, including the chip and all this connections, contacts, and I made a test, and it still gave me errors. Right now I'm in the process of taking it out again and mounted it back here and continue the process that I started, and I have to take out also the chip as well. I cannot show you the errors because I already take out this line of wires here, so it's pretty much disconnected, and probably the errors will not be that evident, but it's what it did. It's a shame it didn't work. I really hoped it was the fault of this connector, but it wasn't only him on this board, unfortunately. Shame. Well, I will have to push on with my original plan to put the one chip and one small connections, and figure out what is going on and why stuff didn't work in the first place. All right, back to the square one. I took out the LCD from this original LCD driver. I mounted here. I took out the chip. The second time, this is the second time when I'm taking it out from there, he got some hit on it. he was a bit mistreated, this chip. But now I have to figure out how to make a board pretty much like this one, but made differently. Instead of making it all at once like I did it here, I will make it one module, one digit driver, one by one, and I will make one single board for one digit, pretty much 7 gates for one digit to drive, and test the hell out of it, and do it like that. This is the proper way. This is the way, actually. This is the way of doing unknown circuits with very sensitive parts like this LCD. This is extremely sensitive to a lot of things. Probably I made already the test. It is working fine now. With this pin holder that it is having right now, is making 100% contact. I made already the test in parallel with that. It's good. It's good to go. Next, I'll have to actually make the driver and see from then. I made a sketch here of how I want the layout to be. Actually, this is the first sketch that I'm having here. Here I didn't know what I wanted to do. I didn't know how to look and how to feel, but I started to form an idea, and then I made this guy here. And here I corrected everything, and now it's better. It's not better. It is the best way I could make it, and is the safest way I could make it. And here is the clean cardboard prototype, and as you can see, it's a cardboard. You see, change light. And yeah, let me describe it to you, what it means and what it does. So this is the 100 hertz that is coming to this pad here, and you can see this pad is connected to this other pad, and this other one, this other one. All these 4 are connected between them because this is the signal 100 hertz that must be connected to every gate. This is the power negative, and that is the power positive pins and pads, and it's clearly marked there and there. Also the outputs Q, A, B, C, and D. These are the outputs, all these 4. This, which is not really, it is showing here actually. I should mark it there as well. So it is the input that is coming from the chip, from the counting chip. So it's the input for gate A. This is gate A on top. This is gate B on the bottom, and this is its input coming from here, from this pad. And C input is from this gate here, and this is the C output. And D input here is from here, and this is the output. So this is the gate D gate, and that's it. Pretty much this is it. How I will mount it, I didn't really think of it because I was concentrated to make it as clear and without problems as possible. And what I'm having now is excellent, perfect, good right now. The layout of the pads and how the chip is mounted on these pads, it's extra mega good right now. Compare with this, which it only had two pads there for the power, positive and negative. That's it, and the rest were wires. Which is, it's fine as it is, but this is extra comfortable for the chip to stay soldered on all these pads that I'm laying here down. I put these extra pads there and there because I will have to link most probably some extra wire, jumping wires, and I don't want to use one single pin for multiple wires that are coming. So one wire will come to this pin from the clock there. So that's one. Another wire will be from the pin to the rest, to this mesh that I'm having there, so it's two. And another wire will be to jump to other chips. So three wires on the same pin is not good. It will spring out the other two when I want to solder the third one. So it's better to have a bigger pad like I'm having there. It's big enough, probably a little bit bigger, most probably. And these are the outputs. I made them this long because I will have also to drag wires from these outputs to here, to this LCD pins. And I didn't decide how I will mount, how I will place this single module, probably here in the bottom, and having the LCD on top, on the top there, or the second idea is to turn it back and put it here on the back. As you can see, this is a cardboard from a chocolate, and if I'm putting it here on the back, probably I will cut some space. You know, I'll make it a little bit more smaller. But this time I didn't think, I'm not thinking on cutting space, on minimizing, on making it smaller, because the price of thinking on everything, this is the price on thinking on everything, failure. This is the face of failure, what I'm having there, a demonstration of failure. So right now I'm concentrated to absolutely have no problems whatsoever, to be as clean as possible from the connection point of view and pads point of view, of course, but mostly the connections, the wiring, because this is the most problematic thing. Wiring are the hardest thing to do. And yeah, we will see when I will decide what I will do. All right, see you later when I will actually build it and test it and check how things will work. It should work. So never give up, never give up. Even if I failed, I was down psychologically. I was depressed because this didn't work. But then I started to remember that I have a lot of shit there. Also, I started to test. The logic mind prevailed, and I'm glad that I have a very logical mind. Although I'm an artist, logical artist, I am a very logical one, and is bothering a lot of people because they think I am an artist and I don't know what is going on in the world. I'm that I'm too wild, but when I start to open my mouth and start to talk a little bit more engineering with them, they are scared. Not really scared, but they are surprised. They are extremely surprised, and they are starting to make all sorts of disbelieving interactions. They don't really believe what I'm saying. They think that I'm making stuff up. Some of the people I encounter, they are that stupid, that idiots, that kind of idiots. All right, this is it. See you later when I will actually build something, and good luck to me. All right. So I made all the pads for this small board, a single digit driver, and hopefully it will be good enough, and hopefully it will work, because right now is perfect from the point of view of the pads and also the chip, how strong the chip is laid down, and also the connections that I'm having. I cannot ask for more. This is perfect. So yeah, see you later when I will actually make the connection probably. All right, what I have here is a test. This is the driver here, comprised only from that chip that I took it out from the first driver there. I hook it up to my signal generator that is running there. This yellow wire is going to that 40 pin of this entire LCD, and then from that 40 pin is jumping to this common pins of the chip. And here are the wiring, the input that is coming from this 4033. So I'm getting the input from this. That is the driver for that LCD. So this chip is providing input for two drivers, pretty much, for that driver and for this driver. I only linked, as you can number, I believe you can number A, B, C, D, and these are only four, because I only have 4 gates inside this chip. I used all the gates, so I only have 4 inputs, and and these are the wire. This is the wire for the output, as you can see, very very long. This is also the output wire as well. This very long wire, output. So all these outputs very long, very long wires. I needed long wires, but it turned out to be very long wires. Doesn't matter, it works. I actually had some problems, very bad luck I have with this driver. I had some problem. It didn't work from the very start, but showing all the four segments that I'm actually driving there. I'm not driving 7, I'm only driving 4 because I'm using only this chip, that's it. And I had some problems with the driver initially. When I was pressing, it was working like that. When I was pressing here, it was working. But if it was staying in any other position, if I was moving the board, it was glitching, giving me errors. Sometimes some segments were lighting, sometimes none were lighting. And it turned out, when I soldered these output wires, I believe the output were the problem, or also the inputs. Probably the outputs. When I soldered these output wires here, it snapped off, it springed out from that the leg of the chip. It springed out from the pad. So instead of staying on the pad, this is the leg of the chip, it got like this, you know, it got like a tiny little bit out. And when I press it, I could see it move it. And I resoldered every pin, but it took me like 1 hour. You should think at the level that I'm building stuff, at the level that I am, and the experience I have all these years, I could spot these little details more quickly. But it took me like 1 hour, probably 1 hour, probably more than 1 hour, probably 1 hour and a half. I don't think 2 hours, probably 2 hours. I have no idea. But it took me long enough, and I was so pissed off, and I was, holy fucking shit, I was very annoyed, and very depressed, because even this little guy didn't work. And then I also made a lot of tests as well. I dragged the signal from there, but absolutely no problem. I mean, it was the same thing, the same errors I was getting. The signal from this 100 hertz generator that I'm having it here for this driver chip. So I took the signal from that and put it here with a very long wire, but that didn't solve anything. But I was thinking maybe that's the problem, you know. And many other permutation I did, until I start to realize maybe it's the chip, maybe it's burned, maybe I use it so much that I put the soldering iron on its pins, and probably one gate or one input or one output got shit itself, you know. And then I started to poke around and to look a bit more closely to those legs, and you cannot see them. You think they're looking exactly like they are right now. You cannot see a shadow underneath. You think they are perfectly connected and everything, you know. But in reality, it snapped like a motherfucker. And some, I believe, I resoldered all of them. I have no idea which one was springed out. Probably all of them, they were springed out, because most probably because I've added these wires here and reflowing all the solder, probably that's springed out. And it's a good lesson for me to actually leave a blob of solder there when everything is reflowing, is getting liquid. It will still stay in a solder under a blob of solder. So that's the story so far. So right now it is actually working. I'm not sure how to film this. So that's 7, 8, 9. Let me bring it even lower. 4. So it is A, B, C, D. That's it. Only these 4 here are linked. And whatever number I'm having there, 1. You see, this is 1. This is 2. Is actually showing all those 4 that he can actually show. This is 5. This is 6. You know. And yeah, when I will link the other 3 gates, it will show the entire number. That's it for this part. I'm quite happy right now that I managed to get over these errors that I got. And yeah, it was very bad luck. Very bad luck, circuit. This driver, it got in my way a lot of shit, a lot of details. I'm wondering how these little gates will behave when I will build them here in a continuation to this driver, and we will see after that. If I will get an entire number, all 7 segments with a single driver module, I will be happy then, because then I know everything will work for the rest of them. All right, that's it for now, and see you later. Next, I've added these other 3 gates here. I linked them all with the common 100 Hz wire on the middle pin. I hope you can see it. You see it? There, and there. This was a bit tricky. It's underneath the board, but it's not like the other ones. It's definitely not touching anything else. Positive, common, negative here. And this negative wire is coming from there. And here, so you can see it a little tiny bit. Positive wire that is coming from there, underneath as well. So they have dedicated and very large tracks. They don't intersect each other in any of these wires that I put underneath. They are on their separate tracks or sides, and they are not one on top of the other like it was on that one, or near each other too much. So I'm completely safe with this arrangement that I'm having here. Next, I will have to make a test as well, put the inputs and the outputs back to that display and see if it's working. And if it's working, I will have to make another tree looking exactly like this. Wish me luck. All right, I should have made this movie for a very long time ago. It did pass a very long time. I made a ton of tests, and I had a ton of errors, and a ton of errors I had, and I finally reached some conclusions, but I didn't test my conclusions. I will only tell you the the error, the tests that I made, I don't even remember them. Suffice it to say that I took out everything. I took out. This was the original board that the original driver that I made, and I took out that chip. I made another board. I put it there, and it still is giving me error. You see that little guy there? Is this gate that I'm having here? So I mounted these two little gates here, and I made a new module here. And when I was testing, you see, if I'm seriously now, you don't show now, you motherfucker. Yeah, you see, when I'm pressing there, this little guy here, this segment here is ghosting. As you can see right now, it is ghosting seriously. And I mounted a button there to be more specific when I'm cycling. So see, I have this ghosting here. On the same I was getting to there and there, to that segment and to that segment as well. Random ghosting. When I was having mounted all these gates, small gates that, and then I thought maybe I should step back with this module, and I took out all these three gates, small gates. I took them out, and I leave only this chip here, and I still did get errors with this chip as well. For some reason, it shouldn't have I shouldn't have get any kind of errors with this chip here alone, but I did get. And then I took it out, and it finally I took out every wire, and until I didn't get any kind of errors. And then I started to mount it back. As I mounted back this chip that you're seeing right now, and I made all the connections, and I checked one by one segment, one gate by one gate. I tested the chip to see if it's broken, if it's damaged in any way, and it did show me it is working perfectly. When I tested each gate, it is having 4 gates, and I tested all its 4 gates, and everything worked perfectly as it should be. And so I tested it by itself pretty much, and nothing was wrong. And then I mounted it here, as you can see it here. One by one gate from its package, I link it to this assembly that I'm having here, and slowly but surely I started to get the correct results. And then I said I should mount these small gates, these little gates, and I only mounted this guy, and I'm starting to get some erroneous behavior there. This is 2. We can check there. That is working there. So this is 3, and this. So you see, this is 3, and this segment there. This segment shouldn't be lit here at all, and it is ghosting right now. Is actually showing a very slight ghosting, but it was more serious, more contrast. It was heavy, it was more black than it is right now. Right now, when I'm filming, is looking like it's fine, but trust me, it wasn't fine at all until this episode when I'm filming right now. I did leave a lot of time. I had a flu, and I had to occupy all my time with the flu for 8 days, something, 7-8 days, and it was horrible. And all my time I had to dedicate to the flu and to get well, and I am well right now, but I kind of lose the flowing of things that I started here. And pretty much this is all that I tested. And my conclusion, after all the errors that I got, my conclusion is that these little gates that I was blindingly trusting them, I was experimenting with them. But one thing I was asking, I was putting myself the question, why does it work flawlessly without any kind of problem here on the breadboard, but here on the cardboard and here is giving me a ton of errors? And one very interesting idea that I got is that I didn't insert these little gates here on the breadboard. They are nowhere. There are 2 chips, longer chips, like this one, and that's it. That's why it's working flawlessly. That's why it's working perfectly here on the breadboard. And I was mistakenly believing they are the same, and they are not the same. These XOR gates, they are the same as the function that they are doing, but the manufacturer, the guys who made these XOR gates is not the same. They use they most probably they have something, a different technology inside. Probably these are made with I don't know, one sort of transistors like BJT transistors probably, and these are made with MOSFETs, or the configuration how they put those transistors there is different. But these little guys, they are definitely giving me errors here on the display. And this longer, more stable, more older chips tested by time are absolutely perfect. They are not giving me anything, any error, any trouble when I'm building on the cardboard. So the next step is to take out this thing that I'm having here and to put this longer chip, bigger chip in continuation, exactly like I'm having it here on the testing breadboard, putting there. So this idea with the small guys, and that I didn't test it at all on the breadboard, it was a immense waste of time, effort, and everything else. And I didn't listen to my advice to test everything before starting laying down. I was trusting blindingly that they will do the same job as the bigger one, and they didn't. And they pose and they inserted a ton of errors, and also I spent a ton of time mounting them. And yeah, that's a lesson. That's a lesson for sure. And let me cycle through this. This is 6. Now see, this is 7. It is 7 there. And this ghosting, it was more problematic It was more evident here than it is right now. Right now, you don't actually see it, and it's kind of fine, you know. But nah, it was terrible. It was terrible. It still is if I'm closing everything. So if I'm closing it, you see, this is the ghosting that it remains after I'm closing the power. I'm switching off the power. It's kind of here as well. It was more elements than it is right now. Huh, weird. It's weird that I'm getting that 8. Anyway, so now I'm powering it on. All right, everything else disappears, but that element there, this is a 5 here. That element is still ghosting there. So these guys are not good at all. They are inserting a ton of errors, not a ton of problems. That's a very bad experience from my side. And yeah, don't try stuff on the final board, especially new stuff, new components. Test them first and then laying them down after testing, after you are sure, completely sure they are working, because you will get crazy believing you are stupid. And in reality, they are the problem, the little fuckers. So this is it for now. Like I said, I spent a ton of time trying and undoing and trying to figure out where is the problem. It is simple right now when I'm speaking about it, but when you don't know what the fuck is going on, and it's passing days and even weeks, is mind blowing hard. It's just you don't want to make electronics anymore after that experience. Trust me on that. Work with work clever, a bit more clever. Test everything. That's the clever way. Test everything and solve the problems. All right, this is it for this part. Thank you very much and see you later. I decided to actually show how I'm making this continuation. So I took out all those small gates, uh, XOR gates, and I put these larger chips, and I remade this link, as you can see here, is exactly as in reality, as I make it in reality. And now I'm pretty much, I made my mind. I keep the same configuration as I was having it originally, with the exception that I will take out those little buggers from here, from the bottom and there on the top. But I will keep the positions because all the wiring is there and already. And I will have to make this secondary board with these 3 chips. And why not 4? Because I will use 1 gate. I only need 3 gates per chip, and the last and one of the digits will borrow 1 gate from each of these 3 chips on the bottom, and will make another digit pretty much. So that's it's a bit weird, but here is how I am building, and how I'm dragging and building everything and fitting everything. And I want to show you the process of making it, and it is this simple. It's very simple, like that. And here is 3. So I preserved all the connections that were made before. I only replaced those little fuckers with these larger chips, which have inside of them already 4 gates, and I'm using only 3 gates per each chip. And then I will use one single, the last gate remained for 1 digit. That's it pretty much. And I already made this 2 guys here. I have the designators. So 5, this is A, you see, 1A. 1D is 6. 1, 2, 3, 4, 5, 6. You see, 6 is this line here, and is D, and C is this. And I didn't I forget to change it. Okay, and let me actually pin it like that, and to have it all the time open here. Yeah, okay, and what? Yeah, I don't really need it all the time open. Only for this C guy that I'm having here right now, and it's okay. Probably this guy here, just to look pretty. No, I cannot work with this. I will have to move it here on the other screen, and let's see, like that probably. Yeah, yeah, right. All right. This is says BB because it remained from the last. Let me do it like this. From the last, I didn't change them because I was concentrated on this, how to make it. And this will go here actually. And yeah, this is the last gate, actually the green gate. I will make use of the other gates, the remaining other gates of this chip. And voila. And if you are wondering how to change the color, I'm changing it from here for each stick that I'm using. So this, let's see on the green here, what I have. I have A, B, G, and F, or green on the top there, and here on the bottom. So this 4 on the top, and on the bottom, 13 and 14. 13 and 14, this first two, 13 is A. So this will be A. Okay, and I will actually move it here to know exactly. So there. Huh. Or to make it like this. No. You see here remains something. So yeah, this is A. This is not A. This is A here. So this and this will be the next one, D. And 14. 14 is D. So this will be so this is D. D, and this is also D. So it's a bit confusing probably. Eh? All that matters is to know exactly which is which. But I'm building here a little bit of convenience on the wiring. And when I'm building the wiring, I want to be convenient from the wiring point of view. So yeah, I believe I'm yeah. So let's see. So this is 13. Yeah, okay. And C. This is C here. This is C. So let me bring up the and C. All right. So let's check it out again just to be sure. 13 is A, and it is here A. Let me move it like this. Yeah. So 13 is A, 14, which is this in the middle, is D, and C is 15. 15 here, and here's this C guy, and that's it. This is the extended chips that I needed to add, and they are also powered. They have this red positive wire on all its pads. This negative wire also on their pads, and only the output wires for the chips. I didn't include the input wires. Actually, the input wires are coming here, somewhere here. In reality, I'll have to deal with this somehow to take out that board. But this is the driver. This is the driver for the LCD. I was actually wondering why I'm making it like this with discrete chips, and why not use a single dedicated chip. But check this out. I actually searched for a static LCD driver IC with parallel inputs and outputs, of course, and I couldn't find anything. I didn't search high, strong enough, was this static LCD driver, namely this V6108. But the problem with it is serial clocked input. So pretty much this is the serial data input and output. I'm not sure the output if it's serial. It appears to be parallel per each pin. So it's per each pin, which is parallel pretty much. But the input is serial. So by doing it my way is very big, is consuming a lot of space. But if we are making abstractions of the space that is occupying, if we are closing our eyes for the space that all these chips are occupying, it is immensely user-friendly because it is parallel input. For each gate I have, so these are the inputs here. So you see next to B, let me actually draw it for you. So all the blue lines are the outputs. And here, this is the input, and this is another input, and this is another input, and this is another input. All these red inputs are driven from from my logic that I want to do, and it's extremely user friendly to do it in this parallel mode, in this parallel way, dealing with each input and 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 driving each input whatever I please, with whatever pin I please, with whatever logic I please. So that's the convenience, and that's why I'm building all this. This quite complex driver, if you think about it, it's quite a complex. That's why I'm sticking with. That's why I'm continuing this driver to build it the way I'm making it right now, because it is very easy to drive. Driving any logic with parallel driving is extremely easy. Doesn't matter what it is. So let me repeat for you again. Doesn't matter what it is. If it's parallel driving, if you drive it with parallel logic, it's extremely easy. It's very user friendly. It's very intuitive. Extremely intuitive to drive it. If it's serial, is losing the intuitive side of things. It's way more harder to drive when using serial, especially if you have to add some binary stuff there, some registers bullshit. It's fucking hard. It is not pleasant. It is not a pleasant experience. While if you have to repair something here, you can repair it. If you have to change something, you can change it. If you have to debug some shit, like I already debugged it, and I already figured it out that these chips are not actually compatible with with other 4030 with the 7486, I think it was. They were not compatible at all, but they are compatible if they are from the same batch, from the same set of chips, from the same family of chips, the 40,000 family in this case, in my case. And yeah, that's my suggestion. That's my direction that I'm doing all these things. So this is my driver. for more clarity, this is the driver that you are seeing here. This is only all the chips used for the driver for the LCD, and it is a bit complicated indeed. All right, this is it. I wanted to show you how I'm dragging the wires, how I'm building a little bit of the circuit and a little bit of explanations. And next, I will have to add the other logic, which I is not showing. So this is the actual logic that I will have. This is the brain, the computer, which we are seeing here. And it didn't select everything for some reason. So here it is. Somewhere there, I will have to drag it and mount it somewhere there. And this will have to, yeah, you see, here is another, you see, it remained from the last time. I didn't even reach this stage here, but this will have to actually drive all of this stuff. So yeah, see you on the other side when the driver will work. Hopefully. Wish me luck, because I did had to swallow a very hard and painful pill with these chips, with the incompatibility of the chips that I used. Yeah, see you next time. And bloody success. Fucking hell.